All right, so we're going to go over acid nomenclature. In addition to ionic and covalent nomenclature, we have special rules that govern acids. Acid nomenclature is a subset of ionic nomenclature, is the kind of the way I like to think about it, because acidic nomenclature is governed by charges. So think about what we did in ionic nomenclature. You always balance the positive and negative in order to reach the zero sum for the compound. So we're going to be doing the same thing here with acidic nomenclature. We're going to be balancing the charges till they equal zero. So all acids contain one or more acidic hydrogens. An acidic hydrogen is an H+. So acids are caused by the presence of a hydrogen ion. A lot of times the way we talk about acids and bases is to talk about them in reference to pH. pH is literally a measure of the concentration of these acidic hydrogens in a solution. So every acid that you come in contact with will have an H+. Remember that H+ is the same thing as saying an H+1. All of these are going to have a positive 1 charge, and it is the presence of the H+ that actually makes an acid. So when we are looking at a formula for an acid, it will always contain an H+, and it will also always be marked with the little parentheses AQ. AQ stands for the fact that it is an aqueous solution. AQ itself stands for aqueous. What that means is a compound or a solution that is aqueous, that formula will break into its representative ions in solution. So whatever the H is bonded with, when I put that into water, it separates into H+ and then the negative ion. And again, it's the presence of the H+ and how much H+ there is that determines how strong of an acid we're dealing with. So there are two groups of acids, two kind of categories of acids. We have binary acids, which is an H+ and a nonmetal. So when we say nonmetal, think about where those are located on the periodic table. We're talking about a hydrogen and anything up here above the stairs. So you're like, wait a minute, isn't this just like what we did with covalent? No, this isn't the same as covalent because we're talking about the charge of the hydrogen as being positive, and then we are balancing that charge with the negative ion over here. So how do I tell the difference visually when I'm looking at a binary acid versus looking at a covalent compound? It has everything to do with the fact that your acid is going to be marked with an AQ. If it's marked with an AQ, it is an acid. You would treat it as an acid. You would use the rules of acid nomenclature that we're getting ready to go over. If it is not marked with an AQ and it's hydrogen with something above the stairs, then it's just a covalent compound. So you have to really pay attention to whether or not there's an AQ there. The other type are ternary acids. This is an H+ with a polyatomic ion. And with our ternary acids, knowing the name of the polyatomic ion, we're going to then change the name following a set of rules just slightly to indicate that we're dealing with an acid. So let's look at the binary acid rules first. So again, this is hydrogen, the H+ with a nonmetal. In words, we use the beginning part hydro to represent the H+, and then the nonmetal ending, we change the ending to ic, and then we toss acid on the end. So functionally, it sounds like hydro, whatever the nonmetal is, ic acid. Okay? The most common one that you would know from previous classes would be hydrochloric acid, HCl. Hydro representing the hydrogen, chloric for the chlorine, and then acid to tell you it's an acid when it's in the name. In the formula, we are still just going to be balancing our charges. So we're going to balance the charge of the nonmetal with the charge of the hydrogen ion, H+, and then you have to add AQ at the end. Again, if you don't add the AQ, it's not an acid. So you got to make sure you add the AQ. So let's go through some examples. We're going to do 6 examples here. So we're going to go from names to formulas first. So anytime I'm dealing with an acid, whether it is a binary acid or a ternary acid, if I see the word acid, the first thing I'm going to do is I'm going to write an H+. All acids have an H+. So hydro, in this case, is H+. It kind of reminds you, in ternary, we won't have this visual reminder of the hydro, so you need to really depend on the fact that it says acid there. So hydrochloric acid, so hydro, whatever the nonmetal is, ic acid. So chloric goes back to chloride or chlorine, and that's our Cl. And the charge of Cl, we know that chlorine is in our 7A column, so the charge is going to be -1. And then all we're going to do is our drop and swap as usual. So the H plus or H plus 1, the Cl minus 1, we know that's going to be HCl. And then because this is an acid, I have to include the little parentheses AQ there. If I don't, then what I'm telling you I have here is hydrogen monochloride. But the fact that I have the AQ, HCl AQ, tells me, oh, no, this is hydrochloric acid, because hydrochloric acid in water is going to come apart into its ions, whereas hydrogen monochloride may not. All right, let's look at the next one. Hydrobromic acid. So again, acid, I've got an H plus. Bromic comes from bromine, so Br -1 and HBr on the drop and swap, AQ. All right. Hydrosulfuric acid, acid again, so we have an H plus. Sulfuric comes from sulfur, S-2. So on the drop and swap, we get H2S, and again, AQ. So just kind of a quick note on the endings here. Most of these, it's pretty obvious what's happening. The ending is dropping and changing to IC. With sulfur and phosphorus in particular, it seems a little odd, but the UR in the sulfur stays because sulfic acid or hydrosulfic acid just simply does not sound right. So it's hydrosulfuric. And then when we have phosphorus, the same thing, that R stays around. So it changes. It seems like it changes just slightly the pattern, but it doesn't. It's just the fact that when you say these things, it sounds odd if you don't have them, and that's why they're brought back. All right, so let's go the other way now. HF, so we know that I've got HF and I have AQ. So I'm for sure dealing with an acid because I have that AQ marker. This is hydrogen and just a nonmetal, so I know I'm going to use the hydro whatever-ic acid format. My nonmetal here is fluorine, so this is going to become hydrofluoric acid. Okay. You have to include the word acid, just like you have to include the little brackets AQ. If you don't, it's wrong. Okay? You can't just call this hydrofluoric. It has to be hydrofluoric acid. All right, H3P. So again, hydrogen, non-metal, phosphorus. AQ tells me it's an acid. So this is going to be hydrophosphoric acid. Okay. And last one here, H2SeAQ. So hydrogen, a non-metal with AQ. So definitely dealing with an acid. Hydro, Se is selenium, so selenic acid. Okay. All right, let's talk about our ternary acids. So ternary acids, we're dealing with polyatomic ions. So we have an H plus with a polyatomic ion. We don't use the hydro in the name here. Instead, we're going to change the ending of the polyatomic following a set of rules. So our rules are, if the polyatomic ends in ate, like sulfate, phosphate, nitrate, we change the ending to ic. If the polyatomic ends in ite, sulfite, nitrite, phosphite, iodite, we change the ending to us. And for those couple that end in ide, they also go to ic. For the formula, we were going to balance the H plus with the charge of the polyatomic, and again, we add the AQ ending to indicate we're dealing with an acid here. So let's look at some examples. So the first one, sulfuric acid. So remember that ic goes back to 8, so this is sulfate. so sulfate, SO4 minus 2. And then remember, we have acid. All acids have an H plus. So just like we've done previously, drop and swap. The 2 goes to the H, the 1 goes to the sulfate. And when I write this as my proper balanced formula, H2SO4 AQ. You have to have the AQ there. If you do not have the AQ, once again, it will not be correct. All right, next one, phosphorous acid. So the lack of the hydro, once again, tells me this is a polyatomic. Phosphorus, us, goes back to ite. So phosphite, PO3 minus 3. And then we have to balance that with the charge of the hydrogen, H plus. 3 to the hydrogen, 1 to the phosphite, H3PO3 AQ. All right. For our next one, we have iodic acid. So ic goes back to 8. So our polyatomic here is iodate, IO3 minus 1 with the H plus 1. Plus 1 minus 1, I don't have to do anything on the drop and swap there. So HiO3 AQ. Okay. And the last one of the names to formulas, perbromic acid. Remember, perbromic, ic goes back to 8. So this is perbromate. Perbromate is BrO4 minus 1. The acid tells me I've got an H plus. Plus 1 minus 1, I don't have anything on my drop and swap. HBrO4 AQ. Okay. Let's go the other way now. So H2Cr2O7 AQ. So the AQ again there tells me, oh, I'm dealing with an acid. I know that the H is my acidic hydrogen, so I need to look at what my polyatomic here is. So Cr2O7 is dichromate, ATE. We're going to change that to ic. So this is going to be dichromic acid. Okay, remember, you must include the acid as part of the name. No hydro, again, because this is a polyatomic. HNO3AQ. So once again, the AQ tells me, oh, this is an acid, and I can recognize, here's my polyatomic. NO3 is what polyatomic? That's nitrate. 8 goes to ic, so this is nitric acid. Okay. Next one, HClO3AQ. Presence of our AQ once again tells me, oh, that's right, this is an acid. ClO3 is my polyatomic chlorate. So when I'm looking at chlorate, 8 changes to ic, so this is chloric acid. Okay. Last one here, H3PO3AQ. AQ tells me dealing with an acid. Our PO3 is phosphite. Ite goes to us, so this is phosphorous acid. Okay. So again, remember, if it is a acid in the formula, you will always have an AQ. Then you need to determine what's the hydrogen paired with. If the hydrogen is paired with a polyatomic ion, you don't have hydro in the name. You simply change the ending of the polyatomic according to our rules. If I have hydrogen and only a nonmetal, I'm going to use the hydro whatever ic acid. For both types in the formula, I will always have a hydrogen balanced with the charge of whatever it's paired with, and there will always be an AQ. Remember, if you do not have an AQ, it is wrong. You must have an AQ in my class if you are telling me that something is an acid.